Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations. My name is Geoffrey Cann, and today's conversation is going to be all about this very rapidly evolving and extremely interesting world of artificial intelligence, machine learning, data science, and how these technologies and innovations are having immediate application in the broader oil and gas industry. And for this, I'm joined today by Morgan Eldred, who is I'll let you introduce yourself, Morgan, but suffice to say the founder and leader of a company called Digital Energy based in the Middle East. Welcome to Energy Innovations.
Thank you, Geoffrey. Welcome to be here.
And so, background, you're the founder or CEO of...
Founder, yes.
Yep, yeah, exactly.
Correct. I'm the founder of Digital Energy.
Brilliant. I have had the distinct pleasure of visiting the Middle East on more than one occasion. You're coming to us today from where?
Dubai.
Dubai, beautiful Dubai. Now,
yes.
let's begin with just getting everyone watching this video centered on terminology. How do you distinguish between artificial intelligence and machine learning? What is in the actual world where you deliver these solutions to organizations? How do you distinguish between these two things?
Well, machine learning is a subset of artificial intelligence. So you could think of artificial intelligence as the big overarching technology, and machine learning is a subset of that, as is deep learning, reinforced learning. They're all parts of artificial intelligence.
And so when people do talk about these technologies, they do conflate them and kind of make them sound as if they're all the same thing, but clearly they're not. There are some differences between the two. So when we hear things like of AI, we should be thinking about machine learning as something that is an element of artificial intelligence and not the other way around.
Correct. Absolutely right. So think of artificial intelligence as the robots that move, talk, walk, and machine learning is a subset of that within the software where a machine is able to learn. And it's able to put weightage. Itself is able to put weightage on statistical models.
I understand. How what's the history of these tools? It's almost as if they have they've been bubbling away in the background. Suddenly they're everywhere. Like what's the storyline behind them?
Well, they've been around from the 50s and the 70s.
Yeah.
I mean, none of this stuff is brand new. Of course, with I think the rise of IBM's Watson, which is what they started calling cognitive computing or marketing it as. That was really kind of where machine learning started to come into the commercial domain and the public domain, where people became more aware of it. And it's been about 8 years since that's occurred, maybe more, 9 years. So it has been around, in mainstream for quite a while as well.
On IBM's big, was it called Deep Blue? Was the name of the kind of the chess playing application, which was, as you say, was very media prominent a decade ago. But these tools have, naturally enough, they've made their way into the energy industry. Are they effectively de-risked at this stage, or are they still pretty novel? How does the oil and gas view these tools?
I think the oil and gas industry is still viewing it as novel. I think the application has not necessarily been there. The use cases are starting to come to fruition. But the actual algorithms that the solutions are backed up from, they're proven in other industries. Financial services, retail, things that's more kind of B2C, where there are large data sets. I think the oil and gas industry still looks at it as a little bit risky, i.e. the use case might be risky, or the way it's being applied has not been done in the industry in some cases, but the technology is proven.
But I think an element of this is the fact that the oil and gas industry relies on standards, standardization, and compliance as one of its ways to assure safety and performance. Are there standards at this stage that the industry could point to in this particular technology arena, or is it still pretty open?
Well, the standards are pretty open. So the European Union is trying to put together some frameworks. Those frameworks are more about the trust in AI and trust in the decision making, and ensuring the decision making is done for good, not for bad. In terms of within the industry, there is no, let's say, a right application of it. So when you are working with or when operators work with oil and gas companies like myself, they really need the likes of us to guide them, to show them the accuracy of the model, to really kind of take them through the decision making, ensure that they understand what is explainable AI, and making sure that they've got some frameworks for the decision making, so they can then, they can go and say, hey, they've done their due diligence to now let a machine make some critical decisions.
Yeah, there is a first principles engineering philosophy that's rooted quite deeply in oil and gas, and when that becomes less transparent, opaque, or maybe hard to explain, you can see where the industry would get a little unsettled when they can't precisely say, how did you get to this answer? And I think that's one of the features of these new tools, is that the pathway to a conclusion may not be as linear as a first principles engineering model. Is that kind of a fair way to think about that?
Absolutely. No, it's a perfect way to thinking of it. And then, of course, we also have, the oil and gas industry, of course, has always worked with big data sets. We've always had, we call it IoT now, but there's always been operational technology, your distributed control system, your SCADA. So there's always been lots of data that has been coming in.
Right.
And there's always been lots of models. We've done work with seismic, massive data sets where there is uncertainty that has been done. And so what tends to also happen is kind of the oil and gas industry, some of the people that don't really understand what a data-driven solution is, i.e. the data and the machine is driving the decision, and it's you're not in control of the weightage. It's something kind of new for them, where they might actually think they get it, but they don't necessarily really get it.
Yeah. It's kind of is still somewhat obscured. Is there more than one way for companies to deploy these tools? Do they have to sit, say, inside company firewalls, or are there a variety of ways that these tools can play out?
Oh, absolutely. So you can have it, on your premise, so in your own data center. You can have it in your own cloud. So in your own, if somebody's gone cloud, they can have it hosted in their own cloud, in their tenant. And then there is more of the traditional SaaS model that's there. There is also, for specific use cases, some where the computing is done at the edge, so within the field. It really all depends, but there are multiple deployment options.
So you could put one way to think about this, I suppose, is that these tools are shrinking in physical size. You can put them at the edge, and by that, a controller, say, that's managing a beam pump or controlling some other device. That shrinkage is something that's been ongoing in the digital industry for 40 years. It should continue to do so, which means that we should be seeing these tools starting to reach into more and more interesting areas in oil and gas for automation.
Absolutely, yes. Because the big use case that everyone goes on about, and that's almost really beaten it to death, is predictive maintenance.
And of course that implies if you think about it, a more central way to kind of optimize maintenance. But with these tools, the device itself could actually look at its own maintenance profile and then signal, hey, I need maintenance over here, and kind of step back from having a sort of essential point of failure with a large integrated maintenance operation. I think that model is, I don't know how far away we are from that model, but that looks like a pathway that this technology could take.
No, absolutely, and that's where the machine to machine really can start to look at it, because if you start to look at it, all of these pieces of equipment are connected to a bigger system. And so understanding the downstream impact of this, and when the machines can talk to each other, then of course it could say, hey, you need to take me out of, I need to come for maintenance. Right. You need to take me out of the cycle.
Yeah, when we get to fully autonomous vehicles, you can start to see where that becomes an imperative, actually. Like the vehicle will, there's just so many things you could monitor on the vehicle that you'll want the ability for the vehicle itself to inform the decision around when it should be maintained or brought in for maintenance and service. Now, what is it if you're building one of these solutions? What are the critical ingredients that you need to have in place? I mean, you've already mentioned big data, but what does that mean exactly? Big data.
Okay, so you do want to have a good data set that you can teach the machine to learn from. Although there is techniques such as transfer learning, where if you don't have a huge data set, you can transfer the learning from one model into a new model. There is reinforced learning where the machine kind of learns optimal parameters against itself. So it's almost playing a game against itself to find the optimal parameters. So in a lot of cases, yes, you do require big amounts of data, and you need, size, you need volume, and you need velocity within the data. But there are not all use cases require huge amounts of data set, because the data, the model might already be applied, and then it's just applying it into a workflow.
So an example of that, if I just think about an oral example, where you're talking to a machine that's interpreting the spoken word, and then that model is learned. So someone's done that work. You've just transferred the model to effectively a new chipset or a new application. So there isn't the learning requirement. Might need to
exactly learn, correct.
Yeah, might need to learn the terminology, but the structure of oral language is, if that's already been codified, you don't need to relearn that. You can apply that quite quickly.
Exactly correct.
Yeah. So this also suggests, so aside from data, how much computer horsepower now is required to actually take an algorithm and run it? Is it heaps and heaps, or are we talking about stuff that can run now on a chipset?
I mean, this stuff can run on laptops. Usually, like it can run on laptops. In a lot of cases, most of your models can run on a laptop. Now, obviously, depending on the size of the data and the speed to process it, you might need some more advanced databases, such as you have one trend at the moment is GPU-powered databases. So typically, your databases work on a columnar level, or basically it works at an index level. And when you can do kind of microprocessing at scale, what you can do on a GPU, you can actually start to crunch billions, data points that are in the billions, in real runtime. So and now that needs some GPUs and some high-end compute, but for most of the basic models in terms of optimizing your planning, optimizing your logistics, finding kind of forewarnings in, let's say, some safety aspects, all of that can be done on a modern laptop.
On a laptop computer. So we're not talking huge investment here for organizations interested in exploring these tools. It literally is, a couple $1,000s worth of hardware. And most people in oil and gas would already have a laptop, so it's not even incremental dollars. Yeah. Right,
and then of course you're going to host it on your servers, or you're going to host it in the cloud. So of course you get your compute from there. But to get started to prove it, you don't need huge amounts of compute. Now, what you do need to have is they do call it artificial intelligence. So it is artificial until you put some human intelligence into it. Right. So you do need to spend some money on some intelligence going in to build, the right models, because that's what you are paying for.
Yeah.
And you are also paying for, and this is one of the things that I think a lot of organizations don't necessarily realize, and where a lot of data science and AI companies have failed, has been going kind of cross industries into something they don't necessarily know, because you don't want to spend 6 months for somebody to figure out what a well is, or what a pipe is. So you do want to have that industry expertise, that knows the data sets, can look at the data and can kind of start adding value from day one. So you do need some industry intelligence to go in.
Yeah, it's the kind of that domain expertise is really the key. So if you have your domain expert who doesn't understand and appreciate these tools, now they execute, you can marry them up with the AI machine learning professional, and good things will happen over a laptop.
Yes, correct. Well, now it's also a lot better if the data scientists can actually speak the industry language too.
Oh, of course, yeah. It'd be faster, certainly. Yeah.
Much faster.
Now, there is the problem here of going back to my data sets. Many people in oil and gas would argue that the quality of the data sets that they have retained is suspect because for a variety of reasons. Haven't invested in them. The context for that data may now be absent, and therefore it's without that context, it's easily misinterpreted or misunderstood. And then the data might just have, bad data in it, like outliers and the like. How are these tools set up now to cope with this? Because this can't be just an oil and gas problem. This strikes me as something that is endemic to anyone who's collected data over the years.
No, absolutely correct. And I think it's almost a red herring. I'm almost, I see it almost as a way for people to procrastinate not to do something. So there are techniques where you can take, in a couple of hours, let's say, do a deep analysis, a few days, realistically, and you can run through the data and you can see where there are black spots. You can see where there is inconsistencies. You can see where there is some anomalies, as in it looks like this data has just been copied over and over and over. So all of that stuff can really be identified very quickly in a snapshot to give you a very good understanding of how to approach it. But, you talked about language. We all don't speak, human communication is only 20% verbal. And not all of us are great verbal communicators. I know, yeah, exactly, right. But we're still able to communicate. We're still able to do that, and that's information. So the machine can do the same. If you look at it, most oil and gas companies have more than enough good data to be able to approach the problem.
So what holds the industry back from addressing this? Is it just a misplaced sense of fear, a heightened sense of fear that's really not material? Is it just running so hard, keeping the machine going, no time to step back? What blocks companies from moving forward here?
7 to 8 years of very low oil prices. Right?
Yeah,
I think
true.
that has been a major barrier. But I mean, if I'm looking at now, obviously the world's it's a new world. It's like we've jumped back in time 10 years. Mm-hmm. And I'm just seeing, everyone is a lot more open now because the cash is there. How do we optimize? The purse strings are starting to loosen up, and money is being spent. So I see a lot more money being spent now. That has been there, and of course, oil and gas, is typically an industry where 99% of the people are QA, very risk adverse, and only 1% is somebody trying to do something. So that has not also helped it. But I think now is the time when it's really going to, kickstart. People will start to see the value. The use cases and the impact is immense. I mean, it truly, truly is immense if it's done the right way. There are horror stories about organizations taking on way too big projects, maybe working with the wrong companies, and there has been a lot of failure, right? So there is some nervous there. So, there are partners and there are companies out there that do this very, very well and very successful. I know I am one, right?
Well, you're in the center of the Middle East in the connections. We're going to talk a little bit about use cases in a second about that. But I think that is the concern and risk in the industry may be misplaced here, and it may be time to explore these tools a bit more thoroughly. Now, there's a convergence going on too. You mentioned earlier robots and the idea of a robot which is executing guidance or instructions that, say, a machine learning algorithm has informed. There's a convergence pathways here where the machine learning and AI tools merge in with other tools. What are some of these convergence pathways that you're seeing take place with these tools with other technologies?
Well, I'm seeing the first one I am seeing is, and this is just because we've recently completed a project, and we have a case study that we're presenting at OTC, which is all around optimizing offshore marine vessels. And we can cut out about 30% of waste, and that means if you've got 10 vessels going down to 7, I mean it's really astronomical. And that is through optimizing the schedules, so integrating with let's say planning systems on the operator sides, looking at where the plans are, where the books are, and then being able to just make sure that you take one route kind of all the way around, and it can have intertransfer, back transfers in it, doing that as opposed to taking one trip here, one trip there, one trip there. And that starts to integrate with the AIS systems of the vessels. So you are starting to connect with their positioning systems. Eventually you would be able to connect with our control systems. So it's not just the schedule and the manifest and the route that you're taking that's done by, let's say, a software part of the machine, but then the whole vessel can become a machine. It's part of the machine as well, which is what you're seeing with autonomous cars, which are further ahead.
Yeah, but the logic is still solid, which is the vessel becomes part of a mesh, if you like, a network where its movements are fully optimized relative to conditions. In the use case that you've described, is this live or is this
Live? Yes,
it's live. And how many? Just out of curiosity, how many platforms were the vessels servicing?
well, I think this it's servicing, so it's live in a few places. It's with one of the world's largest it's literally with the world's largest offshore marine company.
Operation, yeah.
So they are servicing platforms all over the world.
And using this optimization engine. Yeah. What are the sorts of benefits come when you, I mean, the obvious one, if you go from some 10 vessels down to 7, well, you didn't have to spend the capital on 3 vessels. So, or if you had the capital, you could take those 3 vessels and deploy them somewhere else. So you can actually grow the business based on that capital. But what are the other benefits that the operators are telling you?
Emissions.
Surfaces. Emissions.
So emissions are huge. The emissions are huge because you are doing 30%, even with the less vessels, you are doing much less travel. You're moving. You're being smarter in how you move, which actually means your journey time and the distance per vessel goes significantly down.
Any sense as to what the gap is? Like, how big a drop are we talking here?
Well, it will all depend upon how wide the operators will take it, right. How big how many platforms you need to go to, how many vessels are in operations.
Of course, yeah.
But you can basically say anywhere between 20 to 40%
of current fuel consumption,
emissions.
Therefore, yes. direct link to emissions, just less. And I think this is the most important part here: achieve the same work performance.
Actually, weirdly enough, the work performance is actually better because it's actually on time and it's on to a committed time, right? So what typically happens, in oil and gas is you're always sitting at site waiting for people or waiting for materials to show up.
Right.
So now when the material is going to come up, and it's like just in time, so it's better. But that also just indicates how inefficient we are at planning, or how we have just kind of accepted these inefficiencies in our planning, because this is massive. I mean, all this takes is for the operators to be transparent in what they need when, across multiple departments, whether they manage the vessels themselves whether it's the vessels who's a third party, it doesn't really matter.
Yeah.
There is a need of transparency within organizational silos and then probably cross organizations as well. So there is a need to be transparent in data and share it, and then you optimize your plans.
And this is, if you were to translate this to an onshore opportunity, it would have to be orders of magnitude bigger because of all of the vehicle travel and the emissions and so on, servicing the million, just in North America alone, million plus wells. So the upside here, if we can mobilize the industrial change agenda, is enormous.
So we're actually, at the moment, taking the same algorithm, the same system, and we're actually applying it to onshore rigs. And so the difference there is obviously you've got some mobilization times on the rigs. You've got some zones that you come into that take some time. But we are, kind of in our studies, we are saying that we're able to optimize by about 10 to 15% just on rigs straight away. So imagine you've got 40 rigs. Now you've taken a few rigs out, you're demobbing it. You can actually then start to optimize on different parameters. So one parameter could be supply chain. When do I get materials based upon, I need my piping, I need my mud that comes in. Yep. You can do it on emissions. If you want to optimize by emissions, you can also then optimize by your schedule. So I want to deliver this plan within 100 days. You can do it by production quota or production targets. So you can, the whole thing is all the parameters are there to do it. So it's the same technology, and the same algorithm that we've applied offshore, we're applying it onshore, and not just for delivery trucks. We're actually doing it for rigs.
For rigs, yeah. I can imagine a reduction of 10% of your capital asset exposure in rigs, and what will that give you? I mean, the upside would be very significant. And is this in North America, the use case, or is the onshore one international?
So the offshore one is international.
Yeah.
So the offshore one is international. The rig one is that's locally based here.
And what are the technical unknowns, if any, at this stage? That because you're in the world of building these solutions for oil and gas companies. What are the technical unknowns that are out there that still have to be crossed, if any?
I don't think there is, right? So in an example like this, those models already exist. It's just applying those models, again, or just applying them with some different parameters. There's no need to retrain it. Obviously, more data that gets in, it obviously can get smarter and faster and over time. Right. But there is. Now, that's not to say that there's not new use cases that are not coming up, that you're not being worked on, and that there's not unknowns. And typically kind of the approach there is we take three approaches. So first, we make sure that the idea or the concept makes sense. That's number one. Number two, we do look at the historical data just to do a sense check that there is enough to build, let's say if it's a brand new model, to build a new model. And then the third part is a sense check on the organization, if they are really committed for this. Because one of the things is anybody that really goes in to do an AI project, it should not be somebody's pet project. It should have the right management buy-in. This is important to take it and be able to scale at it, because all the AI models themselves are all building blocks. And so you have one building block, another building block. And once you go down that path, you start to become a data-driven company. So you do want to make sure the organization you've got real commitment and it's not just somebody's pet project.
Yeah. And if I were to put this into quite practical terms, imagine you have an organizational structure where the compensation or performance metrics for the ship captain, the vessel operator, are at odds with your artificial intelligence engine, which is now telling you to direct the vessels to sail in a certain fashion. And if that conflict is not sorted, then the benefits will not materialize because the people are being subtly compensated or instructed or motivated to behave counter to what the artificial intelligence engine is telling them is the optimal way to perform. And they could say, well, I'm
Absolutely
doing
correct.
that for compliance reasons, and so I can't, So unless, as you say, if you do this, you're going to be finding yourself bumping up against some deep-seated norms in your own company that you're going to have to crack your way through. And that's why it can't be just a pet project for somebody. It's real organizational heft here.
Exactly. And the impact is huge. I mean, when you start talking about, when you talk 20 to 40%, I mean, that is crazy.
Yeah.
When you're talking 10%, that's still, you still gotta pay attention to that, right? If somebody can say, hey, I can come in and reduce this by 10%, you got to pay attention to that, right? Because you need a damn good reason not to do it.
Yeah, that's material. If you get a 1% and 2% productivity gain in oil and gas, you declare victory and start your next catch a bonus and start your next year. What happens when you start looking at 20, 30, 40% productivity gains? Like it's a real eye opener.
No, exactly.
And where do you see this technology going in the future? I mean, quantum computing's on the horizon. What does this start to do for us as a kind of a future play?
Well, I do see us becoming more. Well, one, it is the real first mover in towards real autonomous operations. That is there. It will be in a lot of cases the leeway to quantum computing. We still don't understand what quantum computing is and how it can be applied to the industry. But there's been some recent breakthroughs in terms of the accuracy of the quantum models that have come out. Now, quantum computing will not solve all problems. You still will need classic computers to solve problems. But I do think it will set the scene for the way that it works. I mean, here's the thing: if you're sitting in your Tesla now, or they're self-driving cars, right? So you're sitting there, you tell them where to go, and you lay back and you play on your phone, you play on your video game, you speak, you fall asleep for a while. So if we can do that, which is going to be a lot more complicated, we can do a lot more of what we do. I think there is a need to get over the hump and for organizations to commit. And there's a lot of use cases in terms of just optimizing your planning, optimizing your supply chain before you have to go into the big bad ocean, deep ocean.
Yeah, the heavy duty, fully autonomous. There's so much value at stake here, just improving what we're doing that we don't have to look too far. Morgan, it's been very useful to get your perspectives from the far side of the planet, but in the heartbeat of the oil and gas industry, which of course is the Middle East. Thank you very much for coming on Energy Innovations today.
Thank you so much, Geoffrey.
This has been another episode of Energy Innovations, and please return to this channel in a few days for another episode. Bye for now.